All right, welcome back to the night class. Today we're going over lesson 6.4. 6.4 is talking about geometric sequences mainly. Now we've already done arithmetic sequences. So arithmetic sequences, what do you do to get the next number? Add. Geometric sequences, what do you think you're going to do to get the next number?
Subtract.
No.
Multiply.
Multiply. Remember, arithmetic is subtracting, okay? Or adding. We don't call it subtracting though. We call it adding a what kind of number? A negative. Same thing here. We're going to be multiplying to get the next number, or we could be dividing, but we're not going to call it dividing. We're going to multiply by a fraction. Everybody with me? Okay. So multiplying by fractions is easy. All right. So for example, right here we have, is the sequence an arithmetic or a geometric sequence? So basically you have to realize, are they going up or down by adding or subtracting, or are they getting the next one by multiplying or dividing? So they went from 3 to 2. So obviously I'm thinking first off they're subtracting 1. But what's 2 minus 1? 1. Well, it says 4/3. So is it arithmetic? No. So it can't be arithmetic. Geometric, let's see. How do you get the rate? What am I going to do? I'm going to take 2 and divide it by 3. So 2 divided by 3 is 2/3. 4/3 divided by 2. Let me show you this cool little trick to divide a fraction by a whole number. You see these two bottom numbers? They're denominator numbers. All you do is multiply them. So that's 4 over what? 6, which reduces to 2/3. Same thing. Okay? If I want to try one more, 8 over 9 divided by 4/3. What would I do? How do you divide by a fraction by a fraction?
Multiply by the reciprocal.
Multiply by the reciprocal. Okay? So those cancel. 24 over 36 reduces to 2/3. So we get 2/3 every time, so it is geometric. You would multiply by 2/3 every time. Okay? Test it out. 3 times 2/3 is 2. Okay? 2 times 2/3 is 4/3. See how we're getting our numbers? Okay? So it checks out. Okay? Now, I didn't ask us to find that. I was just verifying that it was geometric. Any questions so far? Pretty simple? All right. How about that one? Arithmetic or geometric? It is arithmetic. It's being added how much? 1.5 every time. Okay? So geometric has common ratios. Arithmetic has common differences. Okay, common ratio, that's what you're multiplying by. You multiply or you add or subtract the common difference. All right?
So you do geometric is multiplying and dividing, and arithmetic is
adding and subtracting. Correct. Okay? All right? Arithmetic or geometric? 1, 2.2, 4.84, 10.648. What would that be? It is geometric. I love these because pretty much if it's not adding, it's got to be geometric, okay? Now, I have seen some questions that say arithmetic, geometric, or neither, and then you do have to go and make sure that it's geometric. But this book, you only have arithmetic or geometric, okay? How about B?
Can this solely be the test? Can we just not have anything else?
Nah, that wouldn't be no fun. What about that one?
I turned it off and turned it back to
Arithmetic. Adding 74 every time. I don't think that's how you. I think I added an E there. Sorry. Okay. Everybody good?
Yes, sir.
All right. Next example. The recursive formula. Okay. So, if you remember, arithmetic had recursive formulas, and what was the other type called? Do y'all remember? Explicit. Okay? So, explicit, if you remember, you don't need the first well, you do need it, but you don't have to state what the first term is on explicit.
The first term
Okay?
is in the
On right, it's in it. But for recursive, you do have to state the first one. Okay? So what is A1? 8. Okay? And then A sub n. Very, very simple. What are you doing to get the next number? And it is geometric, so you know you're multiplying by something. How do you figure out what you're multiplying by? Just divide. So I'm going to pick the simplest one. 12 over 8. What does that reduce to? 3 over 2. Okay? So all I'm going to do is say 3 over 2 times a to the n minus 1. What does a to the n minus 1 mean? It's the, you multiply 3 over 2 times the term that's in front of the term you're trying to get. Okay? So if you're looking for the 10th term, you take the 9th term and multiply it by what? 3/2. That make sense? Okay? If you need the 12th term, you take the 11th term and multiply it by 3/2. Okay? So that's, again, that's the what kind of formula? Recursive. All right? That is the recursive formula. So you got to know the starting off, and then you can get the rest. All it's saying is, what do I multiply by to get the next number? 3/2. Okay? So that is my rate. That is my factor. In this case, is it a growth factor or a decay factor? It's a growth factor. I'm trying to combine these. Because do y'all understand it's the same stuff we've been doing? Okay? All right?
Since it's over 1, it's
2. All right.
A1.
What's my initial one?
3072.
So, A sub n will equal, what am I doing every time?
Subtract.
You're not subtracting.
Multiplying by a fraction.
Now, I could divide that by that, or that by that, or that, but which one's the easiest to do? 12 divided by 48. Remember, you always do the one after it divided by the one in front of it, okay? 1/4. That sure is a lot easier. I would have no idea 768 over 3072 reduces to 1/4, okay? Pick the easiest one, okay? So it's just 1/4 times what? Yeah, you do. The term that's in front of a sub n. What's the term in front of a sub n? A sub n minus 1.
What's A sub n?
A sub n minus 1. So if this is a 10th, the 10th term, I'm multiplying 1/4 times which term? The 9th term. 10 minus 1 is 9. If I want the 12th term, I'm going to say a sub 12 equals 1/4 times a sub 11. To get the next term, you multiply the term in front of it by 1/4. So if I want 12, I multiply 48 by what? 1/4. If I want 48, I multiply the term in front of it by what? 1/4. Okay? Again, that is the recursive way of doing it. All right? Now, for the explicit formula. It's very simple. Okay? So, here's your explicit.
I don't know it. I don't remember. N1 what? Never mind.
R.
R.
Now,
Common ratio. That's different than it was last time. Isn't it?
that's what it was last time. What were we doing last time, though?
Adding.
Adding. This is not adding anymore. This is the arithmetic one. Okay? Now we're not doing arithmetic. We're doing what? Geometric. So it's different. Okay? This still has the same parts, though. D was our common what over here? Difference. Now we don't have a common difference. We have a common what? Ratio. That's your R. Okay? These are actually much easier than these. So if you thought arithmetic was hard, geometric's easier. So hopefully you'll get these. Okay? So what is the first term?
D.
What is my rate? What am I doing? I don't know it for sure, so I say 12 over 8 is?
One.
It is 1.5, but I'm just going to say 3/2 to the n minus 1 power.
So that's all you have.
That is your explicit formula. Okay? Just to show you it works. If I want, I'm going to use what that, let's see here, 27 is which term? The fourth term. So if I wanted a sub 4, I'm going to plug in 8 times 3/2 to the 4 minus 1 power. Put that in your calculator. See what you get.
It's 27.
Trust, don't just trust me. Verify.
I would actually trust you.
What'd you get? 27. Okay? Always question. Always check. Okay? All right, so a to the 4th is 27. What was our fourth term? 27. Okay? So the explicit formula, well, you can find a specific term right now. If you wanted the 100th term, rather than keeping multiplying by 3/2, 95 more times, all you'd have to do is put in a sub 100 equals 8 times 3/2 to the 100 minus 1 power. It's going to be pretty big, people, by the way. Okay? All right? So, can I do this with the recursive formula? No. Because to use the recursive formula, if I want the 100th term, guess which term I got to know? The 99th. And if I don't know it, I got to get the 98th. And if I see what I'm saying? So it is, the recursive formula is not very good to find a specific term. Okay? You need the explicit formula to do that. Because it helps to know both. Okay? And we're going to, of course, go back and forth. So let's try one more explicit formula. This is, notice, they give you the recursive formula, and you have to write the explicit before you can find the 12th term. Or you can do this 12 times, which is not fun. Okay, so watch how quick this is. A sub n equals, what's my first term?
3.
3. What's my common ratio?
6.
So there's my formula. I just plug in what for n? I'm looking for the 12th term. So a sub 12, 3 times 6 to the 12 minus 1 power. Make sure you do the exponent first.
That's a big number.
It is a big number. What is it?
10, 88, 39, 11, 68.
Oh, really,
Yeah,
really
it's
big.
big.
Say it one more time.
10, 88, 39, 11, 68.
Oh my god.
It's big.
That's a really big number.
That's 1,088,391,168.
Why? I want that much money, guys. That would be very nice.
That would be very nice if you had that much money. You couldn't spend it in a lifetime. Okay.
I can find a way.
All right. You want to try, huh?
I will try.
Example 4.
Gives me that much money.
All right. Says the number of subscribers to a blog doubles each week. How can the trend in subscribers be modeled? So, how much should we start now with?
5.
So, a sub n equals 5. How much is it being? What's the rate?
2.
It doubles, so it would be 2 to the what? Done. Okay? I bet we have to use that for something now. So, the next part. Nope. The number of subscribers to a blog doubles each week. How many subscribers will there be in week 9 if the initial number of subscribers was what? 10. So was that the same, or I think we had? It was 5. So, dang it! Why'd they have to change it? So a sub, what are we looking for? The 9th. Okay. So a sub 9 will equal to the first 9. Initial number was 10. We're doubling still. 9 minus 1 power. So what is 10 times 2 to the 8th power?
2,560.
2,560 blog subscribers. That was not bad after starting out with just 10. And then again, that's how many weeks? 9. That's a little over 2 months. Not bad. All right. Example 6. We're still applying here, okay? It says the number of people attending the annual Town International Food Festival has decreased 20% each year since the first year. How can the attendance for the first 5 years be modeled? Okay? So, the first 5 years, we had how many? Well, how many is the first one? Y'all don't pack up yet.
Don't pack up it.
Okay? So first I got to figure out my rate. Okay? What's my growth factor? Okay? So it's decreasing by what? 20%. So I'm going to have A sub n will be, how many is, we got first, oh, here it is. We got 1,250, okay, times decreasing by 20%. So that would be 0. What? 8 to the 1 minus 0.2. Okay? You with me?
Because it's decreasing.
All right? Everybody understand? Okay. So how can the attendance for the first 5 years be modeled? There we are. So it has us plugging in,
Pretty bad.
I don't know. What was it wanted? Just the first 5 years?
Well, if it's taken in 10 years.
That's what I'm saying. I'm not sure exactly how they're wanting to.
You don't want an answer. I think they just
Okay, they just want the equation?
yeah.
Okay. So we could write it, that would be our explicit formula. If they wanted the recursive formula, we would say A1 is 1250 and A sub n is just 0.8 times A sub n minus 1. Okay? So that would be an explicit formula. That would be the recursive formula. Okay? All right? That's enough for today. Hope you have a great day. And as always, stay above the line.